G'day folks. Yeah, it's another one of those robot cars. This one I built with some help from my grandson Liam over the past few months. So what do we got here? Well, it's Arduino based, Arduino Uno, which you can see in there. It's got 3 wheels. It's got an H drive here, or dual H drive, for the 2 motors. And for steering, it just alters the power to the motors to steer it one way or the other. And it's got like a caster at the front. And originally I did have a caster. It's one of these things off an old chair. But the problem with a caster is that as you change direction and the caster swings around, it tends to veer the robot off course. I didn't like that, so I looked around for some alternative and put one of these wheels on it. Now those who've seen this thing before, or these before, will know that it's an Omni-wheel. It's fixed, so you might wonder how the heck it can steer. Well, it can turn backwards and forwards like that, but it's also got rollers that will allow sideways movement. And that solved the problem of having the car diverted every time you change direction. I looked around for one to fit this particular car. I couldn't find one, so I thought I'd have a go at designing and building one myself, and it works quite well. Well, I could do to be a bit narrower here, but other than that it works fine. It's got 2 small bore bearings in it, and the axles for the rollers are actually bicycle spokes, or sections of bicycle spokes, 2mm. Nice straight spokes, tough steel and smooth. They worked out well. I had another problem with this because there must be some difference in the 2 motors, and over a period of time when it's going forward or reverse, it tends to veer one way or the other slowly. So I put a couple of infrared tachometers in here, and you can see the tachometer wheel here, or one of them, segmented wheel. I didn't have any, I know you can buy them, but I designed and printed that one out too. And that solved the problem of it veering as it went along. So that worked out well. And for navigation purposes, it's got 5 of those ultrasonic range finding devices up here, HCSRO4s, and designed and built this enclosure for it, and also built some electronics into it here to multiplex the signals from the Arduino, because I don't have too many pins left. In fact, there's only 1 spare pin at the moment. So with 3 address lines, so with the multiplexing, I only use 3 address lines, 1 transmit and 1 receive line, and it can actually handle up to 8 of these ultrasonic rangefinders. Now we're only using 5 here, but it's my intention at some stage to put another 3 in at the back, so it can actually reverse and know where it's going. And the software in it, or the sketch I should say, as they call it in Arduino speak, can operate autonomously, and it'll find its own way around based on the readings it gets from its rangefinder. And it's got a battery box under here, got some nickel metal hydride cells, AA cells here, 6 of them, and an on-off switch. And I put a little fuse here just in case something shorts out, because these cells can supply quite a bit of current. I didn't want to let the smoke out of anything. So anyway, let's go and see how it works. I meant to mention that this thing has an infrared receiver here, which is capable of receiving commands from an ordinary infrared remote. There's also got a status board here, which has a red LED indicating ready, and the green LED indicating autonomous operation. The orange LED or yellow LED indicates that it's detected an object within its detection range. So we'll see how it goes. Now, I won't be controlling it here. It'll be making its own decisions as to which way to turn to avoid things. As you can see, the green LED's on, so it's in autonomous mode. Let's speed it up a bit.